Today we're going to look at one of those wireless phone chargers. This is a MI. It was one that was sent to me a while back to use as a comparison for the one I was actually showing off. And I gave this one to my daughter. She used it for a while and gave it back to me and said, doesn't work. So we're going to look at this thing today and tear it down and see if we can figure out what went wrong with it. But I'm not holding my breath. So this is that wireless charging pad that I received a while back. I don't know whether this was, I think this was one of the competition they sent me to compare their product to. And it might have been for the, which one would it have been? Anyway, I've got a couple of different chargers, and one of the companies that sent me one of their chargers sent me, I think, this one and a Samsung to compare their charger to. But we're not doing that video today. We're doing the video on this charger because this one no longer works. My daughter borrowed it and she gave it back to me and it no longer works. This is one of the ones that uses a USB-C, whereas some of the other ones I've got use a standard micro USB. But anyway, when I plug it in, my charger, it's showing, that it's drawing 0.1 amp. And the green light is certainly flashing. You guys probably don't see it here because it's bright in the shop. Trust me, the green light is blinking. You can see it. You can probably see it there. Maybe you can't, but it is blinking. Trust me, the green light is flashing. Even though it's not showing up on camera, I can certainly see it. We'll try this again. This is on the faster charger. You'll see the light will start to blink. There it goes. And now it goes to the faster blink. So we know that it has got power and it is picking up 9 volts from the charger. It won't, however, charge my phone. As you can see, nothing. No attempt to charge. Phone does nothing. The phone should go doo-doo and it should say charging. The phone does charge, by the way, for the skeptics out there that think that maybe my phone has a problem. No, my phone does not have a problem. In fact, the only way I ever charge this phone is wirelessly. That's the only way this phone has ever been charged, is wirelessly. So there's a problem with this charge unit. So we're going to crack this thing open and see if we can find out why it's not working. Did my daughter drop it and break it and then deny it? No, that would never happen. They would never do something like kids. She's 22. Not exactly a kid, but anyway, let's crack this thing open. I think I can get into it if I pop off the bottom. And perhaps we'll see why it doesn't work. It's not like I need another one of these things. I've got, I think I got 3 right now. Let me tell you about the hellish day I had at work the other day. It was Saturday. Was it Saturday? Friday. It was Friday. Go back to work and I have one job to do. And I was at that job for 13 hours. Okay, this is the bottom open on this unit. I don't see much in here. Certainly don't see the charging pad. So let's see if we can pop the top side off on this thing. Like we're going to hammer a screwdriver into it and see if we can pry it apart. I think it's glued. It's glued together. That's why it doesn't come apart. Yeah, this thing is glued all the way around. So now that I've got it worked apart, I can brute force remove the glue. There we go. Okay, there's the unit itself. There's the coil, and there's this little sensor. I think that's probably a temperature sensor here, so that if it gets too hot, this metal, or it's not metal, it's actually ferrite powder, forms part of the core of the transformer, and it's connected down to this. I'm wondering, are those connections no good? Look at these connections down here. This one's the coil, the sensing coil, and this one here is the actual transformer. If the connection was no good, that could certainly make the thing fail. We can actually remove this transformer piece as well, the top of the transformer, and look underneath that, because that's just held in place by 4 screws. I mean, it would be neat to get this thing to work, but I just kind of like to see what's gone wrong with it. Why is it not working? It was working the last time I used it. Oh, that'll lift the whole board out. Excellent. Okay, so this is the whole circuit. And then there's a couple screws that hold this circuit board to the heat sink. There's a little fan on here too, it looks like. Yeah, there's a little fan. That's what this wire is for. There's a fan on here to keep this thing cool. Interesting. What's it say? Do not push cover. So there's a fan to cool the coil, and I guess to keep the circuit board also cooled down. So the problem's either going to be a bad connection here on this where the coil plugs in, or there's a failure in the driver. In that case, we'll take the fan off this thing and toss the rest out. I guess I can test this coil while I'm waiting for this soldering iron to warm up. I can test the coil for continuity. See if we've got continuity here. If we don't have continuity, that would explain why it's not working. We do have continuity. So I'll try to just reflow these connections, maybe even the sensing. Probably it's either going to be a diode or a thermistor of some type. But we'll try repairing or reflowing those connections here. Maybe even on this, check this other one on this capacitor, because there's really nothing else on here other than what's under the shielded cover. There's really nothing, there's not much else on here. We'll take the glue off of the connections here, so that I can resolder them and try that. And if that doesn't do it, then this thing is shot. Speaking of shot, that tip looks pretty bad. Time to make a trip down to Lee's and get a new one, I guess. Perhaps I'll do that today. No, I can't. Today's a holiday. We'll try it tomorrow. And we'll see whether it does anything different. I'm not expecting anything to happen any different than before. I expect that just the LED is going to flash, and that's all that it's going to do. Notice that they did put Loctite on one of these screws anyway. Actually, there's Loctite on this screw too. All the 3 metal screws appear to have Loctite. Little blue. You can see it on the side of the screw there. Blue. That was to keep the screws from, I guess, backing out due to vibration. They probably provide an electrical ground across the board somewhere. Okay, let's just plug this thing back in and see if it does anything. There's the green light flashing. Nope. Not doing anything. So I got that epoxy off here so I can just make sure that these wires here are actually connected. Because if the temperature sensor wasn't providing a correct feedback signal, the unit could be in over temperature shutdown, or at least thinking it's in over temperature. Like, for example, if that component was bad. We'll just test the sensor and see when I heat it up whether this resistance changes. It's measuring about 9K now, so if I bring my soldering iron close to this thing, we should see the temperature, or see the resistance drop, which it is. So it's a temperature sensitive resistor, is what it is. Now it cools down, the temperature, or the resistance increases. So we have to assume that this is probably okay. And how this thing operates is when the temperature increases, once the resistance drops to a certain point, it will shut off. Therefore, I don't think it's a problem with the temperature sensor. I don't know what it's supposed to read when it's cold, but it's probably okay.
I'm going to attempt to take off this shield. I'm not holding my breath that I'm going to have much luck, but let's give it a shot. See if we can get this thing hot enough to remove that shield.
Well, that's not working. The problem is the heatsink's draining away too much heat, so let's just remove this thing, remove the board from the heatsink, and try this again. This thing is so hot now, I can't even touch it. Okay, now maybe I can get this thing hot enough to get the solder to melt so I can remove this top cover.
Of course, you know the problem with this, right? I'm going to get so much heat inside there that all the parts are going to start falling off before I even get the cover off. It's an incredibly secure way to keep people out of your design.
Well, that capacitor needs changing now because the heat has blown the cap. Oh, taking off the USB connector. And I still don't have the top off of it. Okay, the solder's all melted now. And the stupid top is still not coming off this thing. I bet you all the components themselves are going to fall off the board. I'm determined to get this top off now. I don't care if I have to heat this thing up to the point where the solder is molten here. I don't care if I have to heat this thing up to the point where there's flames coming off of it. There goes that cap. It's off the board now. And the solder is molten. And this stupid top. My bench is starting to discolor from the heat. And this stupid top is still not coming off this thing. What the heck? There it goes. Gradually lifting. Now you get to see what's inside this thing. And there's a lot more inside there than you probably thought there was going to be. I only had to get this thing hot enough to melt all the solder around the edges of this thing, which is still pretty warm. But in the process, I took off the capacitor. I melted the plug for the fan. The USB connector fell off. Components inside have come off the board, like that transistor has come off. The transistor would have gone right down there. I mean, something failed in here. Who knows what failed in here, but there's no chance of ever fixing something like this because there's another resistor that's come off there. You know, obviously, likely what happened on this is the unit got dropped and a component came off the board underneath this shield. That's likely what happened to this unit and why it failed. But something like this is certainly not something that you're going to be able to ever service, besides the fact you're never going to get the parts for it. But as you can see, it's all very, very small surface mounted parts. This would be a great one to get that microscope out and we can look at the components under a microscope. So here's what it looks like. This is just under the camera itself, not the microscope. That part's come off from somewhere. These are probably the MOSFET drivers here for the actual coil. A couple of these ones here, MOSFET drivers. I think there's 4 of them the same. HC1621. I believe those are MOSFETs. I haven't looked them up, but I think that's what those are. Those are MOSFETs, so there's 4 of them. Anyway, anything, as I say, anything could have happened to this thing. Any of these components could have failed. Could have been a cracked solder connection somewhere. I suspect that probably there's another part that's fallen off. This is just from the heat, I'm sure. Unless these parts fell off, I mean, that could have been the problem. One of these parts could have come loose off of the board here underneath this can, and I'm sure probably they came off with the heat, but they could have. I mean, that could have been the problem all along, as a component came off because it was dropped, and I'm pretty sure that's probably what happened to this unit. Is it got dropped at some point, because that's what tends to happen with these devices. You've got them sitting on your desk or on your table or something, and something gets moved and it falls down and lands on the floor, and a sharp blow could certainly dislodge any of these surface mount components. It doesn't take much, and that would cause the unit to go into a shutdown mode. And as I say, these are not repairable. So at this point, when I started the video, I thought maybe it was bad connection to the dry, to the coil, the transformer, or possibly the thermal detection. But they check out, so it had to be something on this actual board itself. And as you can see from the complexity of this board, there's not a heck of a lot anybody's going to be able to do to fix something like this. First of all, just getting into it is impossible. You got to get this thing hot enough to melt all that solder around the outside, and of course, by getting this hot enough to melt the solder on the outside, you're also going to melt all the solder that holds the components on, and you're going to have components falling off the board. So unfortunately, these would never be a repairable item, but I just thought you guys might like to look inside and see what goes on inside one of these chargers before this one makes its way to that big recycling depot in the sky, as they say. So that's it. That's a look at this little charger. Thanks for watching, and I hope you enjoyed this look inside one of these cheap wireless chargers. Thanks for watching. We'll catch you in the next one.